Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Cable management is often underestimated in networking, yet it plays one of the most important roles in maintaining a clean, efficient, and functional infrastructure. Well-organized cabling helps prevent a host of problems, from signal degradation and difficult troubleshooting to outright physical hazards like tripping or overheating. It also supports better airflow, easier maintenance, and future scalability. Without proper cable management, even the best network hardware can become unreliable due to cable damage, confusion during rerouting, or interference between signal paths. Structured cabling is the term used to describe a standardized and organized approach to physical network design. It involves installing and managing the network's copper and fiber cabling infrastructure in a way that ensures clear, logical, and documented paths from one end to the other. Structured cabling typically includes patch panels, racks, horizontal and vertical cable runs, wall jacks, enclosures, and documentation. It allows networks to grow, change, and be serviced without creating chaos, and it provides consistency that minimizes human error and supports future upgrades. Patch panels are a central feature in any structured cabling system. A patch panel acts as a termination point for horizontal cabling runs that connect to wall outlets and workstation drops. On the front of the patch panel are modular jacks that accept patch cables, which can then connect directly to switches or routers. On the back, twisted pair cables are terminated using punchdown blocks, allowing a permanent connection to the horizontal cabling infrastructure. Patch panels allow for quick changes, diagnostics, and cable tracing, all from a central location, without disrupting the rest of the network. To support a clean installation, cable management hardware such as trays, rings, and guides are used to route and secure cables. These components help keep patch cables from tangling, reduce stress on connectors, and prevent unnecessary bends or interference. Cable trays can be mounted inside racks or overhead in ceiling spaces to carry large bundles of cables. D-rings, cable ladders, and cable combs are often used within racks to guide cables neatly from panel to switch and maintain separation between power and data lines, which is important for electromagnetic interference mitigation. There are two primary orientations for managing cables in network racks: horizontal and vertical. Horizontal cable managers are typically installed between rows of patch panels or switches and are used to organize patch cables that connect directly between front-facing equipment. These managers include covers and openings for easy routing. Vertical cable managers are mounted on the sides of the rack or cabinet and help route longer cable runs from top to bottom, often guiding cables to different use spaces where various devices reside. Using both types in tandem results in clean, efficient layouts that reduce signal strain and port stress. Punchdown blocks are essential tools for terminating twisted pair copper cabling. They consist of rows of contact slots into which individual wires are inserted and secured using a punchdown tool. These tools cut and seat the wires simultaneously, creating a reliable and permanent connection. Two main types of punchdown blocks are found in networks: 66 blocks and 110 blocks. 66 blocks are considered legacy and are typically used for voice installations, while 110 blocks are higher density and support the bandwidth requirements of Cat5e and above for data networks. The 110 block is the modern standard in structured cabling for terminating horizontal runs. It is designed to support high-speed Ethernet by maintaining twist integrity close to the termination point and minimizing crosstalk. These blocks are often mounted behind patch panels in wiring closets and are connected to front-facing RJ45 jacks. Because of their small form factor and compatibility with modern cabling standards, 110 blocks are the preferred termination point in high-performance networks, particularly those requiring certification for gigabit or 10 gigabit Ethernet. Keystone jacks and wall plates are also part of the structured cabling ecosystem. A keystone jack is a modular snap-in insert used for terminating a cable at the wall or patch panel. These jacks are terminated with a punchdown tool and then snapped into wall plates or patch panels to create an RJ45 outlet for connecting user devices, Wall plates provide a professional finish and keep cables secure and organized at the user end. They are often labeled and color-coded for quick identification, helping technicians trace connections during troubleshooting or when performing upgrades. Labeling and documentation are critical parts of any cabling system. Each cable run, patch panel port, and wall jack should be labeled according to a consistent naming scheme that links both ends of the connection. Documentation should include maps, spreadsheets, or databases that detail where each cable terminates, what it connects to, and what its purpose is. This is essential not only for daily operations, but also during audits, certifications, or emergency repairs. Without good documentation, even a well-installed system becomes difficult to maintain. Another important principle in cable management is respecting the cable's bend radius and using strain relief. Every cable type has a minimum bend radius, which is the smallest curve it can be bent into without degrading signal quality or risking damage to the internal conductors. Bending a cable too sharply can cause signal reflections, increased attenuation, or even breakage. Strain relief ensures that tension from pulling or movement does not stress the connectors or disrupt terminations. This is especially important near patch panels, wall jacks, and cable tray entry points. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. A critical aspect of maintaining a reliable network infrastructure is choosing the correct rack type and layout. Network racks come in several standard configurations, each designed to accommodate different physical environments and equipment loads. The most common are 2-post and 4-post racks. 2-post racks, also known as relay racks, are lighter and primarily support patch panels, smaller switches, or lighter devices. 4-post racks offer greater stability and can support heavier equipment like servers and core switches. They provide more depth and support rails, making them ideal for larger installations. Wall mount racks and cabinets are often used in branch offices, wiring closets, or locations with limited floor space. These enclosures save room while still providing a secure and organized environment for mounting patch panels, small switches, and cable management accessories. Freestanding racks are used in server rooms and data centers and may include additional cable guides, power strips, and grounding bars. Rack sizes are measured in U spaces, where each U represents 1.75 inches of vertical space. Choosing the correct rack type ensures that equipment is properly supported, ventilated, and accessible for service. Network enclosures and cabinets provide additional protection for equipment beyond what an open rack can offer. These enclosures often include doors, side panels, and integrated fans or filters for airflow. Lockable enclosures offer physical security in environments where access must be controlled. Many enclosures are built to support cable management features such as vertical and horizontal cable guides, cable access points, and mounting rails for patch panels and power distribution units. Cabinets also help control temperature by directing airflow through specific paths, maintaining appropriate operating conditions for sensitive electronics. A proper routing of cable paths throughout a facility ensures that cables are protected and logically organized. Horizontal cable trays in ceiling spaces or underfloor conduits are used to move cables across rooms or between racks. These pathways help avoid running cables across the floor, where they could be stepped on, damaged, or become a tripping hazard. Route separation also helps reduce electromagnetic interference by maintaining proper distance between data and power cables. Planning cable paths in advance with clearly defined entry and exit points contributes to cleaner, safer, and more serviceable installations. Bundling cables into organized groups helps reduce clutter and improves both aesthetics and functionality. Cables can be grouped by function, destination, or rack position. Velcro straps are the preferred bundling tool because they can be removed and reapplied without damaging the cable insulation. Unlike zip ties, which can compress or cut into cables if over-tightened, Velcro allows for secure but gentle bundling. Reusable cable ties also support future flexibility. When new cables are added or existing ones are removed, bundles can be adjusted quickly and safely without having to cut anything. Color-coding patch cables is a simple but highly effective strategy for improving cable management. By assigning specific colors to cable types or functions, such as blue for data, red for voice, yellow for PoE, and green for management, technicians can quickly identify and trace connections without needing to reference labels. Color-coded cabling reduces the likelihood of unplugging the wrong cable during maintenance and can speed up troubleshooting significantly. Some organizations even extend color coding to horizontal runs and patch panel ports to enforce end-to-end consistency. Grounding and bonding are critical for protecting networking equipment from electrical surges and maintaining safe operation. Patch panels, racks, and metal enclosures must be properly grounded to dissipate static electricity and redirect stray electrical currents. Bonding involves electrically connecting all metal components in the system to a common ground, ensuring that voltage differences do not arise between different parts of the infrastructure. Following National Electrical Code, NEC guidelines, and manufacturer grounding recommendations is essential, especially in environments where lightning strikes, electrical noise, or large power systems are present. Managing cable slack is another important consideration in structured cabling. Cables should not be stretched tightly between endpoints, as this can place strain on connectors and increase the chance of dislodging or damaging terminations. Instead, extra cable length should be looped and secured in slack trays or cable management arms. This slack provides flexibility for moving or servicing equipment, supports neat routing within enclosures, and helps preserve cable integrity. In racks with sliding equipment like servers, slack must be carefully managed to accommodate movement without stress. Cable management best practices are tested on the Network Plus exam through both direct and scenario-based questions. You may be asked to choose the correct method for labeling, determine how to route cables through a sealing tray, or identify the best way to terminate a bundle of cables on a patch panel. Diagrams may illustrate improperly bundled cables, missing labels, or tight bends, and you'll need to spot the issue and recommend a solution. These questions assess your understanding of how physical infrastructure supports the logical network. Common exam topics also include identifying the purpose of specific components like patch panels, punchdown tools, or rack enclosures. You may see a question that describes a technician terminating twisted pair cabling and asks which block type is being used or what tool is required. Other questions may focus on the differences between wall-mounted and freestanding racks, or the best cable management accessories for organizing patch cables. Knowing both terminology and application ensures you can confidently answer these questions and apply the same knowledge in a professional setting. In summary, cable management is more than just neatness. It is a vital component of structured cabling that affects network reliability, performance, and scalability. From selecting the right racks and panels to bundling cables with Velcro and maintaining proper bend radius, every aspect of cable management contributes to a better network. Good cable practices reduce downtime, simplify troubleshooting, and support future growth. Whether you're preparing for the Network Plus exam or designing a network infrastructure in the real world, mastering these best practices is essential for long-term success. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.